Hey guys, welcome to today's lesson. We're looking at nonlinear relationships, the second lesson in this series, function notation for studies SLIB. Okay, so first and foremost, we're going to start with something that you've done since probably year 7, right? You're given the function y equals x plus 3. We can now refer to it as a function because we know it's linear. We know the vertical line test only cuts it at one spot, therefore there's only one x value for each coordinate. So it's a function. We're given the questions such as y equals x plus 3, find y when x equals 2. Alright, so that's not such a hard question, right? We'd say, therefore, y equals 2 plus 3, y equals 5. Alright, that's pretty straightforward. As I said, we've done that since year 7. Well, the second part of this, well, it's called function notation. It's basically rewriting this y equals x plus 3, but just using slightly different terminology. Because it's a function, we're going to use, and not just because it's a function, but we're going to call it the function of x, f of x, okay, is equal to x plus 3. Now, the f of x works exactly the same as what y is. Okay, they are the same thing. Okay, so I could write it as y equals x plus 3. I could write it as f of x equals x plus 3. I could even go as far as to put like another letter there, like g of x equals x plus 3, h of x equals x plus 3. It works exactly the same way. But basically what will be asked, instead of rewriting it like find y when x equals 2, they say find f of 2. Alright, and that simply means is, well, wherever the x is in my function, I'm simply going to put a 2. So 2 plus 3, therefore f of 2 is equal to 5. Okay, it's not very challenging, and it's not that different, but it is different. Okay, we could have a question such as, if f of x equals x squared minus 1, we could say find f of 1. Well, in that case, it's just 1 squared minus 1, which is 0. They could ask you to find, let's say, f of negative 3. So in that case, negative 3 squared minus 1 equals 9 minus 1 equals 8. Alright, so again, it's not particularly challenging, but as I mentioned, it is different. Alright, and sometimes different things become challenging. There are some harder ones. Okay, so we could do this one, right? Let's look at this. We're going to say EG1 or EG2. I'm going to say if f of x equals x plus 1 and g of x equals x squared, find the following. Let's say we're going to find for A, we're going to find f of 2. For B, we're going to say f of 3 plus g of negative 1. I might say C, find f of A plus g of A. And D, I'm going to say find f of x plus 1 plus g of x plus 1. Now, I'm going easy to more challenging. The first question I'll ask is, why do you think we've got an f of x and a g of x? Why can't I put f of x and f of x? Okay, hopefully the answer to that is, if I put f of x equals x plus 1, f of x equals x squared, and you've got f of 2, you're kind of asking the question, which function do I substitute the 2 into? So in this case, we're saying that this is like the first line. So the first equation, this is the second equation, the first function, the second function. The letters f and g just refer to the two different functions. So when I get the question find f of 2, I know exactly which function this is asking me to sub into. It's asking me to go into the first equation there. So f of 2 equals 2 plus 1, which is equal to 3. All right. Not particularly hard, right? The next question says find f of 3. Well, let's say f of 3 equals 3 plus 1. And then we want to add that on to g of negative 1. Well, that's negative 1 squared. 3 of 1 is 4. 4 plus 1 is 5. Okay, so hopefully you can start seeing what we're doing here. we're substituting the values into the two different equations. In this case, we were placing them. Some people like to put f of 3 equals 3 plus 1, so g of x, or g of negative 1, sorry, equals positive 1, and then add them together. That's fine. Now, what about C? C is just that little bit different. C has got an a there, okay, which means that for the first function, instead of putting a 2 in there or a 3 in there, I'm simply going to put an a in there, plus 1, and I'm adding it to g of a, which is a squared, which means I've just got a squared plus a plus 1. Simples, right? Not that challenging. The next one certainly is a bit harder. We're subbing in an x plus 1 into both of those. So let's do the first one. So f of x plus 1 means I'm putting in x plus 1, and I've got a plus sign, and I'm doing a g of x plus 1, so I'm going to put an x plus 1 squared, and now you can see I can just simplify a little bit. Okay, I can expand these brackets, x squared plus 2x plus 1, and if I can add it all together, I've got x squared. I'm going to run out of room there, so I'm just going to just remove that a little bit, my apologies, and I'm going to put a different color so it doesn't get mingled in that chalk. I'm going to put it underneath here. So I've got x squared plus x plus 2x is 3x, and then 2 plus 1 is 3. It's a little bit hard to see in that purple, isn't it? X squared plus 3x plus 3. And I've simply added all those terms together. So again, guys, function notation isn't particularly challenging, but it is different. Okay, granted. And so you need to practice this. All right. Now, for my students there, we're certainly working on, I believe it is 16A. So if we're looking for some exercises, you weren't in class today, you can do exercise 16A and exercise 16B. That's from the, I believe, the Haas mathematics textbook. Anyway, guys, I hope that made sense. Function notation is important in senior mathematics. Okay, that's pretty much what we use, but we can interchange, so you need to become familiar. Have an awesome day, guys. Any questions, please feel free to give me an email or come and see me. Have a good day.